In this particular video, we'll discuss and understand about components of a vector. Now, last year and even in physics also, you have understood about components, or at least you have learnt about components, correct? Now, what are components of a vector? Assume that you have a vector pointing northeast, okay, northeast. Now, that can be split as north and east, correct? That is northeast. That means here, what we are doing is we are resolving the vector, isn't it? We are splitting the vector into its components. That's what we are going to do, finding the components of a vector. Fine. Now look at this one. See what we have three axes x, y, and z. Okay, so here let's assume that this is going to be the x axis. Okay, then you have this is going to be the y axis, and say this is going to be the z axis. Now the intersection point is origin, which is O. This is the origin. Now we have x, y, and z. Suppose say you have some vector. Let the vector be of any direction. All right. Let's assume that we have a vector somewhere over here. Okay. So assume that this is the point. Say this is A. Now what we are doing, we are going to join O to A. Guys, remember this is in 3 dimension. Correct? Now, so to get to point A, what we'll do, we'll have to go some distance in the x. So assume that this is the distance, and we need to go some distance in the y, and we need to go some distance in the z, isn't it? So what we have, this is the ax, the vector A, but the x component of vector A. Next, so here this distance is a y, the y component, and this distance is az. That means this OA vector, or you can just call it as vector A, has x component, y component, and z component. That means when you take that particular vector and when you split into its components, or you can say when you resolve it into its components, one component will come along x, one will come along y, one more will come along z. Correct? So there are three components. Because see, it's a spatial vector, in the sense it's a vector in space, x, y, z space. That's why we have both all the three x, y, and z component. Correct? Now here, so vector A is equal to ax. Now x component, what is a unit vector along the x-axis? I cap. So ax I cap plus ay j cap plus az k cap. Now this way what we know, that this component is the x component, x-axis component, or you can say that the x-axis component is ax. Correct? The next one is the ay component. So ay is this. So y component is going to be ay. And finally the z component is going to be az, which is here. This is az. Correct? Now that you have understood what is resolving. So resolving is what? It's basically you split the vector into its component form. That is what we call as resolving a vector. And this phenomenon is resolution. Clear? Now, we understood that a vector can be split into its components ax, I, j, and k. Correct? Now, suppose say your vector is like 3i plus 2j plus 4k. 3i, 2j, 4k. That means along the x-axis we have 3 units, along the y-axis 2 units, and along the z-axis we have 4 units. 3i plus 2j plus 4k. Clear? Now what we are going to do, now that you have understood, okay, this is what it is, how do we calculate the modulus? Because a vector has both modulus as well as direction, isn't it? So to calculate the modulus of this particular value, we have mod of vector A is equal to root of ax square plus ay square plus az square. This becomes the modulus of the vector. In the sense, the magnitude of the vector is given by this particular formula. Okay, now comes the direction. Direction is very, very important because remember, when we are looking at two dimensions, suppose say you have just x and y, then you can calculate with the help of tan of an angle theta. Okay, that's very easy to calculate. This is what you did last year. If you remember, tan theta is ay by ax. We used to do that. But here we are looking at three dimension, that is vectors in space. But in space, we have three different angles. That is, the line makes an angle, some angle with the x-axis, some angle with y-axis, some angle with the z-axis. Correct? Which we are going to learn later, what we call as direction cosines. But it's not one particular angle. We are not going to just look at, okay, only with respect to x-axis. No, we have three axes here, isn't it? That's why what we do, we take the basic definition of a vector. From that, we calculate the direction. Clear? So, in this case, what is the basic definition of a vector? We'll start from that one. The basic definition is what? Vector A is equal to mod of A into A cap. Correct? This is basically the case. Now, in this case, if you need A cap is the direction. So, A cap is equal to vector A divided by mod of A. Now, mod of A can never be 0 unless it's a 0 vector, correct? Because you're squaring and adding. That means you are going to have a direction. Now, let me show you an example as to how do we calculate. Suppose say my vector, or you can say that point A is given by 1, comma minus 1, comma 2. First, I'll ask you what is the direction in which this vector is present in the space. For that, first let's try to figure out the vector. See, point A is what? 1, minus 1, 2. That means vector OA. Vector OA becomes 1i. 1i is basically I. Next, minus 1j, isn't it? So, minus j cap plus 2k cap. This is vector OA. Now, let's call this as vector A itself. Okay, so that means vector A is equal to I minus j plus 2k. Now, calculate the modulus. Mod of vector A, root of 1 square plus minus 1 whole square plus 2 square. Correct? So, this is going to become root of 1 plus 1 plus 4. 4, 5, 6, root of 6. So, modulus of the vector is root 6. That means the A cap, the direction, A cap becomes 1 by root 6 times I minus j plus 2k. Now, you all might be thinking, how is this a direction? Where is the angle for a direction? Correct? Now, this is where direction cosines, which you guys are going to learn in this particular chapter, direction cosines are used in calculating the angle. Okay. Now, once you understand direction cosines, then of course you will have a lot of problems and examples related to that. Then you guys are going to understand very, very clearly as to what the direction of the vector is in the space. Okay. Anyway, now the whole point of this is, how do we find the component? And once you find the component, which component is what? Anything along the x-axis comes with I cap, anything along the y-axis comes with j, and same thing with the z-axis you are going to get in terms of k cap, what we call as the unit vectors. From that, you get the resultant, or you can also say the magnitude, root of ax square plus ay square plus az square. Clear? And direction can be found out by this particular form. Now, this is how you resolve a vector in space.